Hello and welcome to Burris Agronomy U. 2013 is already presenting some interesting challenges, and among those challenges is a challenging question. Do we need to do something extra when it comes to nitrogen in 2013? Can we estimate nitrogen losses following rain? Why do some agronomists recommend 30 to 50 pounds of nitrogen after the soil has been really saturated? Let's start the conversation by highlighting how very different the spring of 2013 has been from the spring of 2012. The next two graphs demonstrate that last year and this year really do exist on either end of the precipitation spectrum. In zones 7 and 8 of Illinois, precipitation is more than double that encountered in 2012, a whopping 7 total inches in some locations. The graph for Missouri rainfall also shows that 2013 and 2012 are different from a moisture standpoint, although the differences are not as exceptional. Now, soil chemistry can be confusing, but if you're involved in agriculture, you probably at least know that rainfall spells bad news when it comes to retaining nitrogen in the soil. In other words, most of us know that excessive rainfall probably means some amount of lost nitrogen. And if nitrogen has been lost, the next logical question is, can you tell how much has been lost? Unfortunately, there is not a simple answer to that question. The exact amount of nitrogen loss can vary dramatically because nitrogen encounters a very dynamic rather than static environment when applied to the soil. As we've said here, the question of how much nitrogen may or may not have been lost is riddled with complications. This makes it really difficult to present 100% reliable recommendations to a grower. This slide gives you a sense of how complicated the soil nitrogen cycle can be. We have nitrogen being converted to ammonium, bacteria transforming ammonium into nitrite, and bacteria converting nitrogen into nitrate. The bottom set of equations is what we're worried about. We worry about nitrogen applied to the soil eventually being lost to the atmosphere as a gas. Nitrogen can be lost by leaching in sandy, coarse texture environments, but in the majority of cases it's volatilized. This process is called denitrification. You should also notice that if denitrification, gaseous nitrogen loss, is going to occur, it must be preceded by the batch of chemical reactions noted above. Since we mentioned denitrification, let's take the opportunity to discuss that topic a little more. One of the first things you should know about denitrification is that it is caused by anaerobic bacteria, bacteria that prefer low oxygen environments. Because denitrification is the outcome of biological activity, we can already guess at some factors that make denitrification more likely. First, denitrifying bacteria are going to need nitrogen in a form that they can access, in a form that they can use. Second, we mentioned that denitrifying bacteria need a low oxygen environment. Finally, those bacteria need to be really active rather than sluggish. Addressing that first point, that denitrification, denitrifying bacteria need nitrogen in a form that they can access, in a form that they can use, we can see that a rather complex series of chemical reactions are needed to get us there. This is one of the reasons that we say it's very difficult to make nitrogen loss predictions. The steps previous to denitrification are a varied mess of biological and chemical reactions that can each vary. Let's give you a sense of how complicated this is. Since nitrogen must be in just the right form for denitrifying bacteria to convert it into a gas, the type of fertilizer you use matters in answering that question. Depending upon the time of year that the product is applied, fertilizers with a high nitrate component will be more prone to denitrification than other types of fertilizer. Because time is needed to convert nitrogen into a form bacteria can use, and because denitrification itself requires time, application timing can also change the nitrogen loss answer. The middle point really brings the complicated nature of this question home. Unlike nitrogen being lost as a gas, many of the steps preceding denitrification actually require plenty of oxygen. So one side of this process requires low oxygen while the other side requires a high oxygen environment. Do you see why giving an answer to the nitrogen loss question gets really complicated? All these different things come into play in determining the rate of nitrogen loss. So answering the question means we have to dissect the process a little bit. One of the first things that happens when nitrogen is applied, especially when we talk about anhydrous, is that ammonia, the ammonia form of nitrogen, is converted into ammonium. We won't get into the chemical formula for this. It's the first one on the list of formulas presented a few slides ago if you're interested. But let's just start by saying that that first step is a pretty quick one. In other words, the time needed for that first step is probably a little more cut and dry than the steps that follow. The second and third part of the process, the steps that convert nitrogen into a form that denitrifying bacteria can screw up, is a biological process. In other words, bacteria make that happen, which means colder soils slow the process down. So in the northern part of the Burris footprint, zones 4 and 5, nitrogen is converted into this easily lost form less rapidly than it is in the southern part of the Burris footprint, zone 8. Because winter soil temperatures are really cold and spring soil temperatures steadily warm, you will notice that the rates at which nitrogen is converted into this easily lost nitrate form tend to be higher in the spring than the fall. But in the spring, even though nitrogen is converted to an easily lost form more rapidly, it's applied closer to planting, which usually results in less net loss because the plant can take up that easily lost form before it's lost. I'm exhausted just saying all of that. But again, I'll ask you, do you see why giving an answer to the nitrogen loss question gets really complicated? The nitrogen cycle is an inherently complicated process. Okay, so there are steps that precede nitrogen being lost as a gas. One of those steps happen really quick. The rate of the other steps vary by location and by when nitrogen is applied. What about the part of the process that we're really interested in? When we eventually get there, how fast is nitrogen lost as a gas when it rains? How fast does denitrification occur? It takes a few days of waterlogged soil conditions for this conversion into a gas to kick into gear. So if you go a few days with really saturated soil conditions, that's when losses begin to occur. A day or two of puddles doesn't do it. A few days of lots of puddles and soupy conditions probably does. Which brings us back around to 2013. If you're in Illinois, Missouri, Iowa, or Indiana, any part of the Burris footprint, you know we've seen more than just a few days of saturated soil conditions. That means some kind of loss has occurred, and now you know why. And it also means that we still have to get some idea about how much loss has occurred. Now, not only has the soil environment been wet, but as you can see on this graph of central Missouri soil temperatures taken on April 30th, the soil environment has been rather cool, especially when compared to last year. That's really important, because the conversion of nitrogen into a gas is caused by denitrifying bacteria, organisms. Soil temperatures again matter. Warm soils mean a more rapid loss of nitrogen as a gas than do cold soils. So it's probably been to our benefit that most of these saturated conditions have occurred during cool conditions. That's probably held the conversion rate to 2 to 3% per day. Remember, that's not 2 to 3% of total nitrogen. That's 2 to 3% loss as a gas per day for that nitrogen that has been transformed into an easily lost nitrate form, a portion of the nitrogen. Again, really complicated stuff, but we're working our way toward answers here. So let's start by saying that gaseous loss of nitrate has probably been held around 3% per day. Remember, I already showed some numbers for how fast we transform nitrogen into nitrate, the lost form. So where does that leave us? If I can figure out how fast anhydrous, for instance, is converted into ammonium, and if I have a chart that gives me an idea how fast that is then transformed into easily lost nitrates, and if I know that nitrates are being lost as a gas at a rate of about 3% per day, then I can begin to guess, I stress guess, what nitrogen losses might look like this year. I'm going to start us out with some assumptions. First, I'm going to assume that about 180 to 200 pounds of nitrogen are being applied per acre. Second, just to give us a place to start, I'm going to assume that fall applications were around November 1st and spring applications were around mid-March. And third, I'm going to assume that soils were saturated for about 12 days. When I take all the numbers that I showed you earlier, and when I combine those with these assumptions, I come up with denitrification rates, nitrogen being lost as gas rates, that range from several pounds to 70 pounds. Location influences that. If we used in-serve influences that. Time of application influences that, etc. Now I want you to notice how many times these numbers hit close to 30, 40, or 50 pounds of nitrogen lost. It happens pretty often, doesn't it? And I also want us to think about something else here. In Zone 8, it's going to be pretty rare that nitrogen is applied without in-serve. It's also going to be pretty rare that Zones 4, 5, 6, or 7 use any in-serve in the spring. When we reduce it back to what growers probably will do, we find that nitrogen loss settles into a little window of 30 to 50 pounds. In other words, we're probably safe to say that if a grower faced saturated soil conditions for the better part of a week and a half, they probably lost around 30 to 50 pounds of N per acre. The previous chart could, I suppose, be used to present some specific region by region, maybe what I would call fuzzy recommendations. In other words, the previous chart can be used to tell you about how much nitrogen may have been lost in a specific region if the soil was saturated for a week and a half, and how much nitrogen may need to be applied to make up the difference. Lots of variation can occur, though, and growers are probably safe to guess that in really saturated soil environments, an additional 30 to 50 pounds of nitrogen will probably get them back up to snuff. The other option is just to wait and see if you see a deficiency and then put on maybe that 30 pounds. Thanks for watching. We hope you'll have a shot at getting things planted soon. We hope this information proves useful, and we encourage you to please send feedback and topic ideas.